The marriage of robotics and aircraft, create these unique things that, we colloquially call drones. And that's one of the really exciting aspects of this program, because there's nothing that really excites kids more than flying robots.
I spent my whole career trying to figure out new ways of getting at the atmosphere. This is about as excited as I've been about an opportunity for really advancing the forefront of meteorology and forecasting. This is a bright time in our field.
I feel like with CLOUDMAP, we've just scratched the surface of where we can get to with unmanned systems investigating weather. We're constantly working as a group to try to make our systems more rugged, fly farther, so that we can go into storm environments and other more interesting places.
The CLOUDMAP project, which stands for Collaboration Leading Operational Unmanned Development for Meteorology and Atmospheric Physics, is a collaboration between 4 different universities: Oklahoma State University, University of Oklahoma, University of Kentucky, and University of Nebraska, funded by the National Science Foundation to study the use of unmanned aircraft in atmospheric physics. Oklahoma State University has been developing unmanned aircraft systems for the last 20 years, which gives us a lot of advantages in terms of developing these systems and this technology, providing an integrated capability not only in developing the technology but also educating the next generation workforce.
So one project that I've specifically been working on is at the Little Sahara State Park. I was able to take a multitude of images using a Phantom 4 Pro platform and then stitch them together to create a high fidelity model. I'm taking that model and comparing that to atmospheric data that I had taken using an M600 that had an anemometer measuring wind speed and direction on that. And by including the topography with the atmospheric data, I'm able to show or prove that what we think the atmosphere and land interaction is actually accurate.
We have engineers working with data scientists, working with computer scientists, working with atmospheric scientists. One aspect of the CLOUDMAP project that is pretty unique is the combination of all these different fields, which opens up new opportunities for early career faculty to be able to develop new marketable skills, not only for themselves but also for students. But at the end of the day, it's about taking these capabilities and using them for the greater public good, primarily increasing our understanding of the atmosphere, improving forecasting, and saving lives.
Drones or unmanned systems are able to provide a really unique opportunity to study the chemical composition of the atmosphere because they allow us to reach new areas of the atmosphere.
In the past, we've been able to just get snapshots of it and had to kind of stitch together our understanding of what was happening between this sample and this sample. And now we've had campaigns where we were out flying our aircraft every 15 minutes. So every 15 minutes we're collecting data up to 1 mile, 2 miles, and you can actually see the atmosphere starting to evolve.
We also have a laboratory here in the Weather Center where we do a lot of sensors development and characterization so that we can get the best possible weather measurements that we can. And we have access to the Oklahoma Mesonettes Calibration Chamber here in the Weather Center as well. And it allows us a place to recalibrate all of our sensors as needed and validate them against really tried and true things.
One could argue that making measurements with a UAV is not that helpful in understanding how climate patterns are evolving because these are happening on very large scales. But they can be very useful as looking at markers of how the climate is changing.
One of the things we are currently pursuing by studying the changes in chemical composition is we're looking at carbon flux and land surface atmosphere exchange. So for example, during the growing season, plants consume carbon dioxide. So you will see a decrease in the concentration above the surface, and then it will start to increase again as it moves towards the free troposphere. So we can indirectly look at crop health just by looking at how intense the gradient is every day, and we could potentially see if there's a drought coming or the crops are under a lot of stress, if you see something changing in a way that you don't expect.
The use of unmanned aircraft for atmospheric sensing is really a game changer because it provides us this direct capability of measuring in situ directly where we need to get the data in a way that we've never been able to before.
In 5 years, people are going to look at this and say, yeah, of course, we're collecting data with unmanned aircraft systems. Why would we not be? But we know that we were there at the time of its inception